For this section, we're going to graph rational functions. So given a rational function, to graph it, first thing I'm going to do is find the VA, the vertical asymptote. And to do that, we solve the denominator. So if you solve this one, you get x equal 1. Then I can answer the question about the domain. It's going to be everything, all real number, except x cannot be -1, sorry. To find the horizontal asymptote, I look at the degree in the numerator and denominator and compare them. The highest degree here is a 1. The highest degree here is a 1. So this is the case when the degrees are equal. So the horizontal asymptote is the coefficient, the number next to these x's, which is 1 over 1, which is 1. You can pick some extra points since we're going to graph it and check where everything is. Some of the points I usually pick are the x-intercepts, or you can go into the calculator and go to the table and look where x equals 0 or y equals 0. That will give you your x and y intercept. If you need more than 2 points, you can always plug in some more values for x and get the y. So this is how we're going to graph this. We're going to put the VA and HA on the graph. X equal 1. So you go to the where x equal 1 and you draw. This is a vertical asymptote. So it's a vertical line through where x is equal to 1. Horizontal asymptote, it's a horizontal line, in this case where y equal 1. So you go to the y equal 1 and you draw a dotted horizontal line through it. So this is y equal 1. Now you put the x-intercepts to show you where the graph is going to be, or a piece of it anyway. -2, 0 is right here. 0, -2 is right here. So we know a piece of the graph is going to go right here. And to figure out where the other piece is going to be, you plug in some numbers, and it turns out for when x equal 2, y is equal to 4, right here. So we know the other piece of the graph is going to be right here. That's it. That's how you put the asymptotes, vertical, horizontal, then you figure out where the graph is going to be. We're going to do the same thing for example 2. We're going to start the same way. So to find the VA, I'll take the denominator, set it to 0 and solve it. That will give me x equal -2. Domain is everything, but x cannot be a -2. For the horizontal line, horizontal asymptote, we look at the degrees. When you have a number by itself, a constant, that means it's x to the 0. So that's a 0 degree on the top, 1 on the bottom. So whereas this is the case when the degree on the top is less than the degree on the bottom, which tells me that y equals 0 is the horizontal asymptote. So let's put that stuff on here. VA at -2. So you go to the x equal -2 and you draw a vertical dotted line. That's the vertical asymptote. Y equals 0 is the x-axis, so you draw a dotted line on the top of the x-axis. Now we're going to pick some points. It looks like we can pick when x equals 0, y was 3 over 2. So when x equals 0, y is 3 over 2, 1/2, so that's somewhere over here. So I know the one piece of the graph is going to be right here, and the other piece turned out to be down here. You can plug in some numbers. X equal -3, y is -3, x equal -5, y is -1, and you figure out where the graph is going to be, which quadrant. We're going to do one more example, and this one here, f of x is equal to x squared over x minus 1. Same way, same start. Always start with the VA. Take the denominator, set it to 0. That will give me x equal 1. For the h, for the horizontal asymptote, highest degree is a 2 on the top. That's a 1. This is the case when the degree on the top is bigger. So that tells me there is no HA. Of course, the domain is going to be all real number except x cannot be 1. So for this one, we'll go ahead at x equal 1. We have a vertical asymptote. There is no horizontal asymptote. And for this one, actually had an oblique asymptote, which we'll talk about that later. But I'm going to go ahead and graph it just to show you how the graph is going to be. And when I did the x equals 0, I got, so your x and y intercept at 0, 0. When I plugged in x equal 2, I got a 4, -1, -1 half. So what I got here is one piece of the graph is right here, and the other piece turned out to be right here.